Now we try write lecture, section 14.2, double integral. First, give you definition. Let's go, we have a region. Close region, R. And we try make a double integral for this region. We divide our region for some squares. Each square will be AI. And double integral function f x depend x and y dA for region R will be limit measuring delta approach to 0, sum, partial sum, I change from 1 to n, value your function for point x, y, 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 delta AI. This means something similar with definition our integral when we have integral function one variable. Only before we have some integral depend one variable and was as delta x, for example, if it's depend x. Here function depend two variable and our we take it integral for a region, two major, two-dimension object. What kind of property we have for this kind of integral? Okay, I clean here. All properties similar with property how we had before. For example, double integral for region S fxy dA will be C double integral region fxy di. This means constant you can take out. Similar how you have before, if you have sum or differ to function, and if you have taken double integral for some same region, it will be sum or differ two integrals. Plus or minus double integral second function. If you have your region R, you can rewrite like sum two regions and intersection, this part is empty. This means integral for region R will be sum two integrals, one for region R1 plus double integral for region R2. There. Okay, it's great. We can write a couple of more properties similar what we have before. But question, how we can solving this integral? Every time we need to write integral sum and then go to limits? No, we can see what is the relation between double integral and iterate integral. Sorry, I try clear here. Sorry, sometimes it's take more time than we think. Okay. And here we have very important Fibonacci theorem. Fibonacci theorem will tell us first, if your region are bounded x change from A to B and y change between g1 depend x and some function g2 depend x, whereas g1 and g2 is continuous function and segment AB, then your double integral for region R fxy dA will be equal iterate integral from A to B from g1 x and g2 x fxy, this means same function, but here we have integration not for area, integration dy dx. Second part, if your region R whereas x change from some function h1 depend y between two function and h2 depend y, and y change between c and d, and your function h1 and h2 both of continuous function for segment CD, then your double integral equal iterated integral from C to D from h1 to h2 fxy dx dy. This means both of situation your double integral with equal iterate integral is only order integration depend how you can rewrite your region. See some examples. I'm clear here. Iterated integral, we know how it's counting. This means it's no problem. This means problem is solving double integral. It's moving to solving iterated integral. Okay. Let's go first a simple example when you have integral sorry 1 double integral r sine x sine y dA, whereas our region is rectangle with vertex negative pi 0, pi 0, negative pi half pi, pi half pi. This means I'm checking if I have negative pi there and pi there. This is my 2 vertex, and this is 2 vertex for. This is pi over 2, x and y. Here we have our region is very simple. X changing between negative pi and pi, y changing between 0 and pi over 2. Because both of our variable change from some segment, we don't have any function, any relation. It will be order how you can write is your choice. Okay, I write as like y change 0 to pi over 2, x change from negative pi to pi. Here I rewrite function how we have before, sine x sine y. Because x changing from negative pi to pi, inside integral show me how x changed. This means here I write dx and then I write dy. Oops. Equal. Integrate is no problem. We integrate function sine x dx. This means this will be negative cosine x. And we have integral from 0 to pi over 2. Negative cosine x sine y, x changing from negative pi to pi, and we continue integrate for dy equal. Plugging, cosine pi is negative 1, and we have minus, this means 1. Cosine negative pi is negative 1, and we have, oh, just a moment, I think is cosine pi is negative 1. I have 1. Okay, it's better if I'm right. I have sine y. Cosine negative pi is still negative 1. I have 1, and then I need subtract negative 1, plug in negative, it's positive 1, and then I need subtract sine y dy. Looks like I have 0 there. Okay, great. See different example. Let's go. We need evaluate integral region R y over 1 plus x squared dA. Where is R? Some region bounded y equals 0, y equal square root of x, and x equal 4. Make it graphs, and here it will be square root of x, this is 4, something like this. This is our R. If I looking for some function, what order I need here? If my first I write dy dx, this is how y changing. Y changing from 0 to square root of x change from 0 to 4. And then I'm integrate for y 1 plus x squared dy dx from 0 to square root of x. Here is from 0 to 4. How we take it? What order is preferred for us? It's all depend how easy you write your region and what easy integrate your function. What do you have here? One denominator here is work like coefficient. This means we take it integral from y. It will be y squared over 2. And here we have integral from 0 to 4. 1/2 y squared over 1 plus x squared dx, whereas y changing from 0 to square root x. If I plug, I have 1/2 square root 0 to 4 x, because plugging here square root x squared, it will be x, 1 plus x squared dx. If you plug in 0, it will be 0. We can easily doing u substitution, and 1 plus x squared, if it's use u, 2x dx, it will be du, or I write myself now, it's 1/4 natural logarithm 1 plus x squared. 0 to 4. Plug our border, we have 1/4 natural logarithm 16 plus 1, this will be 17. Great. But how changing my solution if I'm taking different orders? Try solving same integral, same double integral, but if we have order integration dy dx, this means first we integrate for y, then we integrate for x. Now I'm changing. I'm looking what happened if I'm integrate first for x and then for y. Okay, clear here. Sorry, sometimes it takes longer than with solving, but we try. Okay, now I have integral, and you remember I want to doing different order. This means first integrate by x, then integrate by y. Function is same, 1 plus x squared. Then I have dx dy. But how am I x changing? X changing from 0 to y squared, right? Because x equal y squared. How am I y changing? Y changing from 0 to 2. Great. And then we have, if we integrate for x, 1 over 1 plus x squared, it will be arc10x. And here we have integral from 0 to 2 y arc tangent x arctangent x dy, whereas x is from 0 to y squared. Plugging, and we have integral from 0 to 2 y arctangent 10y squared dy. How you can see, this integral is more complicated than we have before, and because it's only example, I'm show you this will be, if we use u substitution, it will be 1/2 integral arc 10 u du from 0 to square root of 2. And after integrate, I skip this part because it's all you remember, it will be integration by part. And here it will be u arc 10u minus ln square root 1 plus u square. And plugging your numbers, it will be 1/2 square root of 2 arc 10 square root 2 minus ln square root of, okay, 2 plus 1, this will be 3. Both of solution is correct, but I think its first method is Moss's first example, not method, first method. First example was much easier. One more time, both of is absolutely correct. This means if you're moving from double integral to iterated integral, every time check what will be much easier, what is give you more reason for solving. Okay. How we can use double integral? Looking at more examples. We can use double integral for found value. Doing some example from book, and then we talk. Okay, first clear here. Let's go. I try found double integral. I try found volume, use double integral, and I need found volume, some object, where is z equal 4 minus x squared. I think I need to write a little bit lower. Okay, just a moment. I clear all of them. Z equal 4 minus x squared minus 2y squared. 2y squared. All we know, this will be paraboloid, and we need found between this paraboloid and xy plane. xy plane. This means you have something like this part. like cup, upside down. Okay, how we can do it? First, we're looking what has happened if where our paraboloid intercept for xy plane. This means z equals 0. Z equals 0. Have 4 minus x squared minus 2y squared equals 0. Or it will be x squared over 4 plus y squared over 2 equal 1. This means here, if you take it x, y plane, you have some ellipse, whereas x changing from -2 to 2, and x changing from -2 to 2, and y change, oops, I need more place for write how y change. Y change between negative square root 4 minus x squared over 2 and square root 4 minus x squared over 2. And now we have region, we need to take it integral. What will be integral here? Volume, it will be double integral for this region from your function, value your z, this means 4 minus x squared minus 2y squared dA. Or it will be, if you're moving for iterate integrals, it will be x change between -2 and 2, y change between minus square root 4 minus x squared over 2, square root 4 minus x squared over 2, our function 4 minus x squared minus twice y squared, and now we have dy dx. Oh, practically we're solving because it will be our integral, iterated integral. You can looking from book, and it will be, finally, it will be 4 square root of 2 pi. Because this is example from book, you can read in the book, but I'll only show you how it's come. Okay, now solving some question similar for your homework. Clear here. Okay, sorry. Board with board is much easier. Okay. But today is first time, and see, maybe it's next time it will be better. Okay, let's go. I need found volume. This kind of object I have. Okay. This is my coordinate system, x, y, z. I have plane who intercept my coordinate system. It's 3 here, 6 there, and 4 here. This means we have some pyramid, and our equation, our plane is 4. Oh, it's sorry. It will be 2x plus 3y no, I don't want clear. 3y plus 4z equal 12. And we need found volume this pyramid. Okay, first solving is for z, and after solving I have z equal 3 minus 1/2 x and minus 3 half y. This is my function when I will be integrate. But now I need to see what happened with xy plane, for example. Because we're solving for z, this means we're doing for our integral for region who is xy plane. Okay. If we need region for xy plane, this means z equals 0, and we have 3 minus half of x minus 3 halves y equals 0. It's give me a line. This means this kind of triangle, whereas x change from 0 to 6, and y change from 0 to until 2 minus 1/2 of x. Now we're ready for found our value. Value will be, we can write as double integral for region or iterated integral, whereas x change from 0 to 6, y change from 0 to 2 minus 1/3 x. Just a moment, I think I have made a mistake, 1/2 x. One half x, and here we write our function 3 minus 1/2, 3 minus 1/2 x minus 3 half y, and this is dy dx. Integrate, we have integral from 0 to 6, three minus half x, it will be like coefficient, this means only multiplied by y. Here we have minus 1/3 y square, y from 0 to 2 minus half of x dx. If we plug in, we have some 14/3 minus 16 9x plus 7/54 x squared dx, and after integrate you have 14/3 x minus 8/9 x squared and plus 7/54 x cubed over 3. Plug in your your number 6. Finally, we have 16/3. I have a couple of questions for you. Just a moment. I think we're doing one more example, and then this question about how we're doing exam and quizzes. Okay. Well, first I'm clear. And now after I'm clear, I can talking about I think it's end of week I give you some quiz and I write some question. Maybe it will be from your homework, maybe it will be very similar in your homework, and see how it's work. You can send me picture you're solving, or any other way, and use my email, and I'm grading and putting. And will be great if we have one more exam. And about final, I think now maybe I give you a couple of questions and you prepare, and then we're doing face-by-face exam. Maybe different, maybe it will be more similar like normal final before, I think. But now my suggest for you doing your homework and send me question about your homework. Okay, one more example. Here we only count in double integrals. Double integral x e power y dA, whereas our region is y bounded y equal 4 minus x, y equals 0, and x equals 0 for this line. 3 lines. This means you have triangle here. 4, 4. This is our region. We have integral. Well, I think we save order dy dx. This means here is x changing from 0 to 4. 0 to 4. Oop. I don't need green, I need black. Y changing from 0 to 4 minus x. Here I have x e to the y dy dx. Integrate first step is no problem, and you have integral from 0 to 4 x e to the power y, whereas y is from 0 to 4 minus x dx, is equal integral from 0 to 4 x e to the 4 minus x minus, if you plug in y0 it will be 1, this means minus x and dx. Only problem with found integral x times e to the 4 minus x. Here, oh, I'm sorry guys. Here we use integration by part. We can do it separately. X e to the 4 minus x dx. Polynomial function times exponential function. This means u will be x. E to the 4 minus x dx will be dv. Du will be dx. And v will be minus e to the 4 minus x. We use this fact, we have this integral, it will be, I write here, minus x e to the 4 minus x minus integral v du, it will be integral e to the 4 minus x dx, who is give us one more time 4 minus x. Okay. Plug there, as we doing separately before, plug here, we have minus x e to the 4 minus x minus e to the 4 minus x and minus x squared over 2. Plugging our border 0 and 4, we have negative 4, negative 1, 16 over 2, negative 8. If I plug 0, I have 0 first term, plus e to the 4th degree second term, and 0 third one. This means finally I have e to the 4th minus 9. Okay, I think this is enough for today. Remember, end of week, I think it's Friday, we have some quiz. If you have any question about homework, write today or tomorrow, and I'm answer it and make it some like small lecture or something, answer it for your question and put in the blackboard. Okay, guys, I think we can save our semester and study very well.